In this movie, we focus on the fusion of AI technology and automobile technology and follow the process of ChatGPT debugging to complete the basic operations of autonomous driving such as forward movement, stopping, and deceleration, while conveying the greatness of ChatGPT. We tried to move the autonomous driving robot only with ChatGPT, without human programming skills. We wanted to test whether ChatGPT alone can really move an autonomous driving robot. As a result, we were able to implement the function in just about 10 minutes, which is quite amazing. We hope you will watch the entire movie. We have prepared 3 items for this project: a learning robot called Spike Prime, which is sold by Lego, the Spike app for implementing the program created, and a Python script generated by ChatGPT. To explain more about Spike Prime, it is a robotics kit designed for STEM education and is the successor to Lego's Mindstorms. The kit includes a hub, sensors, motors, and Lego blocks that can be used to construct various robots and mechanical creations. The hub is the central part of the system and can read block-based programming language called Scratch or Python language through an app, and send movement commands to the built-in speaker, microphone, LED display, and sensors and motors connected to input/output ports. In addition to the hub, the Spike kit includes several sensors such as color sensors, distance sensors, and touch sensors. With these sensors, the robot can detect the environment and respond to it, making it suitable for various applications such as measuring distance and color, detecting obstacles, and responding to touch. The Lego Spike Prime kit is the perfect tool to spark interest in robotics and programming, and is a recommended learning kit for children. As a side note, for this project, we will mainly create a car robot with sensors and motors, and implement the program from ChatGPT into it. If you are interested in how to create a car robot, you can find a link to the TacoBot, a car robot released by Carnegie Mellon University on their website. The Spike application that will be prepared is a comprehensive development environment that includes an editor, compiler, and debugger. This type of software is often referred to as an IDE, which stands for Integrated Development Environment. It is installed on a computer for use in programming. The editor is used to write code in a programming language that humans can understand. The compiler is used to convert the program into machine language that a robot can understand. The debugger is a tool that allows you to stop and run a program freely, and view variables and sensor readings. In this case, ChatGPT will be handling the programming and debugging tasks, so it is a testament to the impressive capabilities of the software. The third thing to prepare is ChatGPT. You will create a specific prompt to ChatGPT to generate a program that encourages autonomous driving. The program will then be pasted into the Spike app and tested on the robot. If there are any issues, the error logs from the Spike app will be included in the next prompt and ChatGPT will debug the program. This process will be repeated until the program is completed. There are 3 prerequisites for implementing the program generated by ChatGPT into the Spike Prime robot. Firstly, the libraries provided by the Spike Prime app can be made available to ChatGPT. This means that by specifying the available libraries, the number of debugging cycles can be reduced, and the completed program can be achieved with fewer debugging sessions. Secondly, debugging will be done solely by ChatGPT, using the error logs included in the following prompt. No human intervention will be allowed. This is an attempt to experience the greatness of ChatGPT by relying on it 100% for debugging. Thirdly, the output code will only come from the feedback provided by ChatGPT, with no human intervention. The goal of this project is to experience the greatness of ChatGPT, similar to the intention behind the debugging process. Let's go through the steps of creating the program. First, we will ask ChatGPT to generate a program that makes the robot move forward 30 centimeters at 50% speed. Moving forward is a crucial action for autonomous driving, and it can be achieved by rotating both motors, connected to the left and right wheels, at the same speed. As a starting point, we will check if ChatGPT can generate a program that achieves this operation, using the program created by a human as a reference. Note that the stop control at 30 centimeters is not suitable for autonomous driving and will be removed in a later step. Here is the prompt to input into ChatGPT, a Python script that can be executed on the Spike app. The autonomous car robot uses two motors connected to port C and D as a pair motor to move forward at 50% speed for 30 centimeters. Please also include the Spike Prime library. Copy this prompt using Ctrl+C and paste it into ChatGPT's input bar using Ctrl+V, then press Enter. ChatGPT will start generating the program. Once it is completed, click on Copy Code in the top right corner of the code screen to copy the program. The program generated by ChatGPT is a concise 3-line program with comments added for clarity on each line. Next, open the Spike app and create a new Python project. Then, paste the code generated by ChatGPT using Ctrl+V, press the Connect button on the top left of the screen to connect your computer to Spike Prime via Bluetooth. Once the connection is confirmed, press the Run button on the bottom right of the screen to run the program on Spike Prime. Here is how the program generated by ChatGPT works. Amazingly, it cleared a 30 centimeters forward movement in just one prompt. However, there is one problem. The speed is not set to 50%. Let's try playing it again. This is a program that moves forward at 50% speed, created by a human. And here is how the program generated by ChatGPT works. It seems to be faster than the one created by a human. The prompt should have included 50% speed, so let's debug it with ChatGPT. The code ChatGPT debugged for us is here. You can see that the argument for move now includes 50% speed. We'll check its functionality using the same steps as before. Now it's moving at 50% speed as expected. Now, let's challenge ChatGPT to create a more complex program. We want a self-driving program that slows the robot down to 30% speed when the robot's distance sensor detects an obstacle within 10 to 20 centimeters, stops when the obstacle is less than 10 centimeters away, and resumes forward motion at 50% speed when the obstacle is gone. As a reference, here's a program created by humans that avoids collisions. It forces the robot to stop when an obstacle appears in front of it. And here is the prompt we will use this time. Write a Python script that can be executed on Spike Prime. The robot car uses two motors connected to port C and D as a pair of motors, moves forward at a speed of 50% and a steering angle of 0. Meanwhile, a distance sensor connected to port E detects obstacles in front. If the distance to the obstacle detected by the distance sensor is between 10 centimeters and 20 centimeters, the robot speed should be reduced to 30% speed. If the distance to the obstacle becomes less than 10 centimeters, the robot should stop. When the obstacle disappears, the robot should resume forward movement at a speed of 50% speed. Finally, add the Spike Prime library as well. Enter this prompt into ChatGPT, and follow the same steps as last time to generate and execute the code for testing. And here is the operation of the program generated by ChatGPT this time. It doesn't work at all. When we looked at Spike Prime, we saw this error output. We will create a simple prompt that prompts for debugging, including this error log. From here on, we will proceed with the verification of the operation using the same steps as last time. As a result, it still doesn't work at all. And after repeating the debugging 4 times, here is the completed program. Stop. Slow down. Resuming driving after the obstacle disappears. It took about 10 minutes to complete the program. Now, let me summarize this project. ChatGPT was able to debug a robot's automatic driving program, including functions such as forward, stop, and deceleration, and complete it in about 10 minutes. ChatGPT was able to control the robot's motors using Python, process data from sensors, and adjust operations accurately and quickly as needed. Through programming skills, ChatGPT is expected to contribute to the development of technology and continue to contribute to the field of robot automatic driving in the future. Thank you for watching.